The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video: Square root of an imperfect square with 3 decimal digits. Example: 84,693. Let us set this number in the right side of the abacus by leaving 3 columns, that is 3 set in the thousands column, 9 to the left of 3, 6 to the left of 9, 4 to the left of 6 and 8 to the left of 4. Let us break this number into 3 groups as 8, 46 and 93. Take the first group 8 and consider the highest perfect square there, which is 4. Take the square root of 4, which is 2, that should be set by skipping a column to the left of the number 8. Now 2 is multiplied with 2, which is 4, that should be subtracted from 8, which gives the remainder value 4. Now let us take the remainder of the first group, which is 4, and the second group, and the number becomes 446. Now double the number 2 and set it in the left side of the abacus, that is 4. Now the first digit in the left side of the abacus is 4. Consider this number and take the first 2 digits of 446. There are 11 fours in 44. Under these circumstances, take the highest single digit number, which is 9, and set that as the quotient. Set 9 to the right of the already set 2, and also set the 9 to the right of 4. That means you have to multiply 9 with 49 and subtract the same from 446. That is 9 multiplied by 4, 36, and you should subtract 3 from 4. For subtracting 6 from 4, you should subtract 1 in the higher column and add 4 with the existing 4. That will give you 8. Now 9 is multiplied with 9, which is 81. That should be subtracted from 86, and therefore you will get the remainder as 5. With the addition of the third group, now the remainder value becomes 593. In the next stage, double the square root part, that is 29, and set the 58 in the left extreme of the abacus. Consider 5 the highest digit of the number on the left side, and 5 the highest digit of the remainder. As the divided value is 1, set it to the right of the existing square root 291 and also to the right of 58. Now 1 multiplied with 581, which is 581, that should be subtracted from 593, and you will get the remainder as 12. Now you have to go for your decimal part of the square root. Add 1 0 to the dividend, which makes it 120. From here on, you can simply follow the regular division procedures in getting the decimal part of the square root. For getting the divisor, you have to double the square root 291, which gives you 582. Since 582 is less than 120, your first decimal digit of the square root is 0. That is 0. Now add one more 0 to the dividend and you get 1200. When we are going to the second decimal of the square root, you can round off the divisor and get approximate values. Now ask how many 600s, as 600 is the rounded off value for the number 582. By saying 2, place the number 2 to the right of the present square root, that is 291.0. Now you get 291.02. Now subtract 2 multiplied by 582, that is 1164, and by subtracting it from 1200 you get 36 as the remainder. Now we are going for the third decimal digit of the square root. Therefore add 0 to 36, which will make it 360. Now look at the divisor, which is 582. As the divisor is larger than 360, the divided value becomes 0, and therefore the third decimal digit of the square root is 0. Now we have to go for correction with the third decimal digit. Let us look at the remainder 360, which is higher than the midpoint 291 of 582, and therefore the decimal part of the square root may be rounded off to 291.021. That is, 1 is added to the right of the square root, 291.02, and the square root becomes 291.021. Similarly, we can go for higher number of digits too in the decimal portion of the square root.